Welcome back everybody. Today we're going to be learning how to create a sequencer using ladder logic inside of a Siemens S7 1200 PLC using TIA Portal. Now before we get started, what I want you to do is I want you to give the video a like and comment below what you'd like to see on our next video next week. Now as I mentioned, we're going to be creating a sequencer. If you're not too sure what a sequencer is, think of most automated processes. Most automated processes have a start position and an end position, and they go through a series of steps to reach that end position, and when they've completed the process, they then go back to the start position and then repeat that process. A classic form of a sequencer is what everybody knows, a set of traffic lights. Now a set of traffic lights has the sequence of red turning on first, waiting a period of time, and then turning on the amber. Yes, we're going to use the amber today. Then after that amber has been on for another set period of time, we then turn off the red and amber and then turn on that green light to let the traffic start to flow. Let that run for a period of time, turn off the green, turn back on the amber, wait another 5 seconds or so, and then turn off the amber and then go back to red and let it repeat the stages again. That there is a classic form of sequencer, and that's what we're going to show you how to create today. Let's get started. Okay, so I've got TIA Portal in front of me already. I've already created the hardware, so we don't need to go through that. We're just going to jump straight into the program. Now, when we're creating a sequencer, you don't have to use ladder logic to create that sequencer. You can use what we call SFC, which is sequential function charts or sequential flow charts, however you like to say it. Now, we're going to show you ladder logic today just because it's a very straightforward programming language and a lot of people use it on the shop floor. Now, when we're creating a sequencer using ladder logic, what we're going to be using is Siemens shift left instruction. Now, what a shift left instruction does is it shifts bits within a byte, a word, or a double word left a certain amount of bits depending upon what we set it up as. Now, what I'm going to do is I'm going to show you how we create this so you get a little bit more understanding of this. So the first thing that we need to do is set up the shift register. Now, we need to think about how this set of traffic lights works. We turn on the red first. Right, okay. Do we have any push buttons for this traffic light to run? The answer is no. We just have 3 outputs. We have red, Q0.0, amber, Q0.1, and green, Q0.2. So how do we start this process up when we've got no push buttons? Well, what we can do is we can actually use the PLC outputs. Think about the PLC outputs on the very first scan of the PLC. On the very first scan of the PLC, all of the outputs are going to be a logic 0. They are all going to be off. So what we can do inside of network 1 is we can say that if the red lamp is off, the amber lamp is off, and the green lamp is off, we are at the start of our process. So I'm just going to type in here Q0.0, Q0.1, and Q0.2. And I'm going to rename these tags red, amber, and green. And at this point here, what I want to do is I want to load my shift register with the value 1. This is going to turn on the very first bit, which is going to be our very first step. So to do this, open up our instructions window on the right hand side, open up our move operations, and drag and drop move into network 1. And what we're going to do here is we're going to move the value 1 into MB0. Okay, rename MB0, and we're just going to call this the sequence of steps. Alright. The next stage is to then trigger our shift register, and the shift register, the shift left instruction, is inside of our shift rotate folder. Open that up and you will see shift left. You'll also see shift right. So this is if you want to move the bits right within the binary. But because binary works from right to left, we want to shift the bits left. So what I want us to do is drag in our shift left instruction into network 2, and I want to add in a signal before this, and this signal before this is going to be our strobe signal, our trigger signal, which will shift the bit left when it's completed its step. So I'm just going to give this the M bit M10.0. And what we'll do is we'll just rename this strobe. And like I say, every time a step is completed, this strobe signal is going to be triggered, and that there is going to shift the bit one place to the left. Now what we need to do is we need to tell it which register we're going to be working with, and the register that we're going to be working with is MB0. That's our sequence of steps, and it's going to ask us how many times do we want to shift the bits left, and we only want to shift them one position, and we're going to shift them into memory byte 0 again. So what will happen here is when the red lamp is off, the amber lamp is off, and the green lamp is off, 1 is going to be loaded into MB0. And the way this will look inside of the PLC memory is like so. Memory byte 0, and it will look like that. And that bit that is on is M0.0. Okay, we are in memory byte 0, and that there is the very first bit in memory byte 0, which is M0.0. This is going to be our step 1. Step 1 is then going to control the first part of our process, and when it's completed, it's going to trigger our strobe signal, which is then going to shift this bit here one place to the left. So what it will look like is this. And that bit that will then be on is M0.1. And M0.1 is going to be our second step. When the second step is completed, it's going to trigger our strobe signal once again, M10.0, and that there is going to shift the bits one place to the left once again, and our binary will look like this. And that there is M0.2, and so on and so on. So in Network 3, what we want to do is we want to have the sequence of steps for our process. So we start off with our step 1, which is M0.0, and we'll rename that step 1. There we go. And step 1 is going to be completed when the red lamp is on, the amber lamp is off, and the green lamp is off. Then we can trigger our strobe signal. So what I want to do is I want to tie this to our red, our amber, and our green. Then tie this to our M10.0, which is our strobe signal. Now what I want to do is I only want to trigger this once for one PLC scan. So I'm just going to drop this coil down, and I'm going to select the P, the one-shot pulse positive, and I'm going to give this a storage bit, M1.0, and that there is just going to be our storage bit for our one-shot pulse, SB1. There we go. The next step, step 2, is then going to wait until the red lamp is on, the amber lamp is on, and the green lamp is off. So when the red is on, the amber is on, and the green lamp is on, that then is when that step is completed. So I'm just going to drag that up, and that will then trigger the strobe signal again for one PLC scan, shifting the bit one place to the left, which will then turn on step 3. I'll just rename this step, step 2. There we go. And then we'll start on step 3. So M0.2 will then turn on. Rename that step 3. There we go. And step 3 will be completed when the red lamp is off, the amber lamp is off, and the green lamp is on. Again, drag that up to the top rung, and red, amber, green, just label these contacts. And that then will then trigger the strobe signal, again shifting the bit one place to the left, turning on step 4. M0.3. Rename that step 4. There we go. And that there is going to be completed when the red lamp is off, the amber lamp is on, and the green lamp is off. So red, amber, green. Now we haven't controlled any of these outputs just yet, but the control part is going to happen later. So then finally that will then trigger step 5. Like so. and we'll just rewire the tag, define the tag as M0.4. There we go. And that there is going to be completed when the red lamp is off, the amber lamp is off, and the green lamp is off. When that's happened, these three contacts will be true, moving one back into our sequence of steps, starting the whole sequence again, starting from step 1. So that there is our sequence of steps here. Now we just need to do the control side. So the first part is going to be controlled through step 1. So all I'm going to do here is just type in step 1. And what we want to do first of all is we then want to set the red, turning it on and latching it on. So what I want to do here is just set our red lamp. So then what happens is when step 1 turns on, it sets the red. Step 1 will then be on, the red will then be on, the amber will be off, the green will be off, it'll trigger our strobe signal. The strobe signal will trigger up here, moving the bit one place to the left, turning on step 2, and then the red lamp will be on, and now we're just waiting for our amber lamp to turn on after a period of time, we'll just say 10 seconds. So here, we'll type in M0.1, step 2, and here what I want to do is I want to run a timer for 10 seconds first of all. And then after 10 seconds, we then want to set the amber. Like that. Okay, so now that the amber is set, what we have now is step 2 on, the red lamp will be on, the amber lamp will be on, and then the green lamp will be off, which will then trigger our strobe signal once again, triggering this contact, shifting the bit one place to the left, turning on step 3. Now in step 3, what we want to do is we want to leave the amber on for 5 seconds. Like that. And then what we want to do after those 5 seconds is we then want to reset the red lamp, reset the amber lamp, and then set the green lamp. There we go. Again, now we're at step 3 with the red lamp off, the amber lamp off, and the green lamp on. It's going to trigger our strobe signal once again, shifting the bits one place to the left, turning on step 4, and now we need to have the amber lamp on by itself after a 10-second period of the green lamp being on. So we'll just go to network 7, type in here, step 4, add in another timer. And what this timer is going to do, it's going to run the green lamp for 10 seconds. And then after the 10 seconds, we then want to reset the green lamp. And then we want to set the amber lamp. There we go. So now, the amber lamp is on by itself, triggering the strobe signal once again. That strobe signal is then going to shift it once again, one place to the left, triggering step 5, and now we just need to reset the amber lamp, turning all the lamps off to then restart the sequence. So here, step 5, wait 5 seconds, that, and then we want to reset the amber, and there we go, and that's it. That's that program designed. So let's go over it once again just so we understand how it fully works. So this network here, network 1, just loads our sequence of steps, our register MB0 with the value 1, turning on the very first step M0.0. And that happens when the red lamp is off, the amber lamp is off, and the green lamp is off. That moves 1 into our sequence of steps, turning on M0.0. M0.0 turns on here, and it's waiting for the red lamp to turn on, the amber lamp to be off, and the green lamp to be off. So in network 4, here's step 1, and it sets the red lamp. So this contact will be true, this contact will be true, these both will be false, meaning that the current will flow through, triggering our strobe signal. Our strobe signal will then trigger our shift left, and it will move the bits one place to the left, turning off M0.0, turning on M0.1, our step 2. Our step 2 then waits 10 seconds, allowing the red to be on for 10 seconds, and then after that 10-second period, it then sets the amber. Step 2 is now true, red is now on, amber is now on, and green is now off, triggering the strobe signal, triggering our shift register, moving the bits one place to the left, turning off step 2, turning on step 3. Step 3 is now on, and we wait for the red lamp and amber lamp to be on for 5 seconds. After the 5 seconds, we then turn off the red, turn off the amber, and then set the green, triggering the strobe signal once again, triggering our sequencer, shifting the bits one place to the left, then turning on step 4. Step 4 turns on, it then waits 10 seconds for the green to be on, it then resets the green and then sets the amber, triggering our shift register once again, moving the bits one place to the left, turning on step 5. Step 5 then turns on, waits 5 seconds for the amber to be on, then resets the amber. When it resets the amber, the red lamp is going to be off, the amber lamp is going to be off, and then the green lamp is also going to be off, which will then trigger our network 1 again, moving 1 back into our sequence of steps, turning on M0.0, starting it all up again. And there we have it. We have a sequencer controlling a set of traffic lights on an automatic loop without any push buttons to start or stop the process. So let's test this out. What I want to do is I want to save my project, and then I want to download this to the PLC. Next, I want to just load that into the PLC, and then I'm going to start all, and I'm just going to select finish. Now the problem that we're going to have here is trying to monitor this program just from this block, and you'll see what I mean by that in a second. When we go live, we now have 8 networks to try and monitor and keep up with. Now we could just look at network 3, which tells us exactly which step we're currently on, and that will then progress through the stages. But a better way to do this would be to simply create what we call a watch table. And we did this in our very first video. A watch table would allow us to monitor the signals that we want to monitor. So what I want to do here is I just want to open up my watch and force tables window, add new watch table, and then I want to start typing in the addresses that I want to monitor. So the addresses that I want to monitor first of all is my Q0.0, which is my red lamp, my Q0.1, which is my amber lamp, my Q0.2, which is my green lamp. And what I could do is I could then type in M0.0, 0.1, 0.2, 0.3, 0.4 for the steps that I've created. Another thing which we could do instead of that is using MB0. If I type in MB0, I can then change the display format to binary. And what this will allow us to do is allow us to actually monitor the bits inside of this memory byte, and allow us to see it shifting the bits one place to the left each time that it's triggered. So what I want to do here is I just want to go to monitor all, and we can now currently see that the red lamp is on, and it's waiting for the amber lamp to now turn on, and you can see here it's now shifting through the bits. The green lamp is now turned on, and our bit is now moved across. It then go back to amber, and our bit will move one more stage across there again. There we go. After amber's finished, it'll then go back to the start and then repeat the sequencer once again. And there we go. Now you'll notice that you didn't see the very first step turn on, and that's because it happened too quickly. If we look at what the very first step is, our very first step, step 1, is just waiting for the red to turn on, the amber to be off, and the green to be off. And step 1, all it does is just set the red, and that does that on one PLC scan. Now currently my scan time on this PLC is approximately 1 millisecond. Too quick for this laptop to pick up and actually display in our watch table, so you'll very rarely see that bit ever turn on. It does turn on, but you just won't see it turn on just because of how quick it's actually executing. Now, a great thing about using a sequencer is we can start to identify faults really quickly inside of this PLC just by looking at this network here. This network, if the process was to stop at any point, let's forget that it's a traffic light sequence, we can then just look at which step it is currently stuck at and which conditions it's waiting for to turn on for it to progress through to the next step. And then we can just work backwards from there. So what I'm going to do is I'm actually going to put in a fault here. And all I'm going to do is I'm just going to put in a normally open contact to stop it from progressing any further forward. So what we'll do is we'll go to step 4 and I'm going to put in a normally open contact here. And we'll just address this to an input I0.0 for example. Okay. Now if I save this project and I download that to the PLC, the next time it goes through to step 4, it's not going to be able to progress any further forward because I0.0 is never going to turn on. And as you can see here, we are actually at step 4. The timer has timed out, but I0.0 hasn't turned on. So let's just imagine the process is broken down. All we need to do is go to our sequence of steps here, and we can see instantly that we're stuck at step 4 and it's waiting for the amber to turn on and the green to turn off. Now what we could do here is we could cross-reference the amber and cross-reference the green, or we could cross-reference step 4 and find out what it's controlling. So if I right-click step 4 and I go to cross-reference information, we can see here it's being used in network 3 in our sequence of events, and we can also see it's being used in network 7 to control the outputs. So if we just select network 7, it'll take us directly to network 7, and you can see here that step 4 is on. The timer has elapsed, so it's not the timer's problem, and we can see here that nothing is happening on the output side because this input hasn't turned on. So all we would then do is we then go fault finding on this input, get your multimeter out, and let's go start testing on the electrical side. Now yes, granted this sequence is a small sequencer, it's only 5 steps in length. The largest sequencer that we've personally worked on is 128 steps. Now that doesn't mean to say it gets any more difficult fault finding on it. It remains exactly the same. All that's different is you've got more steps to look at. All we would then do is again just look down our steps, find exactly which step we are stuck at, and find exactly which conditions we need to have on for it to progress to the next step. And that there is how we create a sequencer using a shift left instruction inside a TIA portal. Now I understand it is a basic sequencer, it's only 5 steps in length, granted. The largest that we've worked with is 128 steps in the past, but I don't want to get too in depth with these little videos here. These are just to give you an introduction to certain instructions in certain programmers and how to use them. If you do want to learn more about Siemens TIA Portal and the S7-1200 PLCs, we have both online courses and hands-on training courses on our website. If you go to www.scantime.co.uk, you can find out more about these courses. Get in contact with us if you have any questions, and as I mentioned before, please leave a like and a comment below on what you'd like to see on our next video, and hopefully you might see that next week. We look forward to seeing you again. I've been Chris, thank you for attending.